Imagine you buy a brand new luxury car, but instead of adding standard accessories, you pop the hood, cut into the engine block, and start splicing random wires into the transmission. It actually drives perfectly fine at first, but a year later, the dealer sends an over-the-air software update. The car tries to reboot, hits your custom wiring, and completely dies. The dealer refuses to fix it, and your investment is bricked. This mechanical nightmare matches exactly what enterprises have been doing to their SAP systems for the last 2 decades. Developers have written millions of lines of custom Z code directly into the standard software. When you treat enterprise architecture like a custom sandbox, you build a fragile, tangled ecosystem. And when the time comes to modernize, that entire structure collapses under its own weight. This technical debt always starts out innocently. A business unit asks for a new field on a screen or wants to tweak a standard approval workflow, so a developer modifies the SAP standard to make it happen. Compound those tiny tweaks over a 5-year period. You end up with 8,000 custom objects, hundreds of modified standard programs, and a massive web of hidden dependencies that management doesn't even know exists. This animated diagram maps out exactly how that happens. In a real retail scenario, a department asks for a custom sales order screen. That single modification to the standard transaction spawns dozens of overlapping connections and secondary custom objects over time. Then SAP releases S/4HANA. Because the core system is so heavily altered, developers are forced to manually compare and retest every single one of those scattered nodes against the new standard software. Excessive modification breaks the normal software lifecycle. A routine upgrade that should take 3 months stretches into a paralyzing multi-million-dollar delay that lasts over a year. To fix this upgrade crisis, SAP introduced the Clean Core Strategy. This is a strict architectural mandate designed to keep the standard system as close to factory default as possible. The central rule is simple. Developers must stop modifying the standard SAP code entirely. Instead, they have to build their customizations as extensions sitting completely outside the core software. Think of it like the smartphone in your pocket. In this split-screen diagram, you have a static operating system layer at the bottom and a modular application layer hovering above it. You don't rewrite Android or iOS to get new features. You just install independent apps. By physically separating the core foundation from the innovation layer, companies guarantee routine system updates install smoothly without destroying custom business processes. The mechanical engine driving this separation is the SAP Business Technology Platform, or BTP. This is the external cloud environment where all new business innovations are now required to live. This diagram illustrates the new architecture. S/4HANA sits isolated as a solid central block. All the customizations move to the dynamic outer ring representing SAP BTP. You use tools like SAP Build for custom apps and the integration suite to connect external data, leaving the core untouched. Let's apply this to a manufacturing scenario for a mobile approval app. The standard purchase order data remains safely locked inside S/4HANA. Meanwhile, the actual approval app, the automated workflows, and the user authentication execute entirely within BTP, communicating with the core strictly through standard APIs. In the past, a developer would have fulfilled this request by logging directly into the core system, modifying standard transactions, and writing new screens right into the main codebase. Extracting that logic into BTP creates an architectural firewall. The business gets to aggressively scale their custom applications and workflows without risking the stability of their monolithic core. The operational payoff becomes obvious the moment SAP pushes a mandatory S/4HANA upgrade. Because the core is clean, the update installs instantly, and all your custom BTP applications continue functioning without interruption. Beyond just faster upgrades, this separation dramatically reduces testing cycles, accelerates cloud migrations, and makes it vastly easier to plug in advanced AI tools when the business demands them. To enforce this, developers have to follow a strict decision tree framework for any new request. As this flowchart shows, they must aggressively question if the problem can be solved by standard configuration, an API, or a side-by-side BTP extension before they ever approach the core. Modifying the actual SAP software sits behind that locked gate at the very bottom. It is strictly reserved as an absolute last resort, permitted only if every external solution completely fails. Maintaining this separation turns technical governance into a long-term strategic advantage. It ensures that every line of new code remains a permanent asset rather than becoming a multi-million-dollar liability during the next upgrade cycle. Take a look at this architectural blueprint. You don't shatter your home's concrete foundation every time you want to add another room. You leave the main slab untouched and build modular extensions right next to it. Understanding the difference between those external side-by-side extensions and internal in-app extensions is the next logical step to mastering SAP BTP. I'll break that down in the next video, so make sure to subscribe for more architecture tutorials. And before you go, drop a comment below with the most difficult legacy customization challenge you've had to untangle. Thanks for watching.
Don't forget to subscribe and press the bell icon.